Hello, everybody, and welcome back. Here we have a part 3 of our Module 3 instructional videos, and we're going to focus on triangle angles. Some of the main topics that we will focus on are the interior angles of triangles. We'll focus on their exterior angles, and then lastly, we'll focus on the relationships that exist between those different types of angles. Let's go ahead and get started. So the first thing we'll focus on are the interior angles of a triangle and something we call the angle sum property. Just as a review, if we say interior angles, we think of those as being the angles that are inside of the triangle itself. And the angle sum property, of course, leads us to the fact that we are going to be adding some angles together to get to a specific sum altogether. So here, of course, we have a triangle with 3 interior angles, 1, 2, and 3. And what we know about the angle sum property simply says this, and I'm going to call these angles A and angle B and angle C just for reference. The angle sum property says that if I take the measure of angle A, so M, then you have your angle symbol, and then the label A. If I take the measure of angle A and I add that to the measure of angle B, and to that I add the measure of angle C. In other words, if I take the value or the size of all 3 interior angles, that sum will always equal 180 degrees. We use that in a wide variety of ways, but it's an important piece of background knowledge that we should be aware of that we needed to review first. The other area that we should be able to make a connection to is some of our work with special angles earlier in this module. We should be used to, or at least familiar with, a total of 180 degrees. So it's worth mentioning that while we use 180 degrees for this angle sum property, we also used 180 degrees in reference to supplementary angle pairs. Supplementary angle pairs were those angle pairs that when we in essence stuck them together, they ended up creating a straight angle, which is also 180 degrees, and that idea will come back a little bit in our work here today. One basic way that we use the angle sum property is to take a look at an angle like this, or I'm sorry, a triangle like this, and then try and find a missing piece of information based on what we know about the angle sum of the interior angles of a triangle. Of course, we know that they have a sum of 180 degrees, but what you would be expected to do, perhaps, is set up an equation that would help you find that piece of information. Of course, here, using the angle sum property, I know that the angle that is marked x degrees plus the other two, 63 degrees plus 17 degrees, I know that that will always equal 180 degrees, no matter what the triangle or what type of triangle we have. And then once we get there, we can, of course, simplify expressions and solve. 63 plus 17 can be simplified. And of course, 63 plus 17 is 80. So now we have x plus 80 equals 180. And then lastly, we'd be able to isolate the variable by doing the inverse of adding 80, which is subtracting 80. And we'd just be left with x equals 100. So then we'd be able to find the missing angle size in a triangle. And again, that's a pretty basic way for us to apply what we know about that angle sum property. Next, we're going to take a look at the exterior angles of a triangle. And at first, that's a little confusing because it's pretty easy for us to identify those interior angles, ones that are inside of the triangle, but you might not necessarily see exterior angles right away. And we have to explore them by doing this. One option is to extend the sides of each side of the triangle, something like this, imagining that they keep going in one direction. Although we could do this in either direction. We don't have to follow just this one option that I'm choosing here now. What we end up seeing is that we create these exterior angles, something like this one here, and this one here, and this one here. Now, the reason that we examine these sets of exterior angles, the reasons we explore these sides, is because now we can see that these exterior angles, they pair up with each of the interior angles that we already know a good bit about, because we know that the interior angles, they have a sum of 180 degrees, and that's going to be helpful. But the other thing that we now see is that when these exterior angles pair up with each interior angle, in essence, we get that supplementary pair, and that happens all the way around the triangle for every interior angle and its paired up exterior angle. So we get a supplementary pair on each section, which is going to help us come to a conclusion similar to what we already knew about the interior angles. Here's what I mean. If we know that each set of, or each pair of interior and exterior angle is supplementary, that means that each one of those pairs comes together to make 180 degrees. Well, if that's true, then that means we have a total of 3 different pairs, or supplementary pairs, that are also 180 degrees. So to look at the exterior angles, we could take all 180 degrees and add them together and start to learn a little bit more about the exterior angles. Of course, 180 plus 180 plus another 180 is actually 540 degrees. And that's a great starting point, but what we've included here are the measurements of the interior angles as well. So we have a little bit too much when it comes to looking at the total sum of our exterior angles. So how are we going to find out the actual total of our exterior angles if right now we have a combination of exterior and interiors? Well, even though we don't know the individual size of each angle in this diagram here, we do know that the total angle sum for all 3 of them is 180 degrees, which means if we take the 540 that we had for all 3 pairs, we could simply take away all of the interior angles by subtracting 180 degrees, which leaves us with a grand total of 360 degrees. So that's what we now know about our exterior angles, which I'll abbreviate for just the moment. So our interior angles have a sum of 180 degrees, while our exterior angles, all 3, have a sum of 360 degrees. That'll be important to keep in mind as you move through the lesson. The next thing that we'll discuss is something called the exterior angle theorem, which still applies to these exterior angles. And the exterior angle theorem works something like this. If we had a triangle, as you can see here, with the given information, would we be able to find the value of that exterior angle labeled x? Now, there are a variety of different paths that you might take. One might seem a little straightforward because of what we already know about an exterior angle and its interior angle pair. We already discussed that they're supplementary. So if we had known the value of this angle right here, well, then we'd be able to use that knowledge about supplementary angles to find what's missing. Of course, right now we don't have that value, so that's not an automatic process. Could we find the missing value here? And of course we could, because we also know that the 3 interior angles, or the angle sum of a triangle, is always 180 degrees. So we could start by finding this value simply by saying, well, y plus 20 degrees plus 130 degrees is equal to 180 degrees. That would allow us eventually to solve for y. And once we know the value of y, we'd say, oh, that number plus x should also equal 180 degrees because, again, these 2 angles form a straight angle and therefore are supplementary. And that would work, and that would be a wonderful problem-solving process perhaps to use. However, we're going to use a slightly different strategy, and that strategy, again, is this exterior angle theorem. And here's how that works. The exterior angle theorem says that the measure of an exterior angle, like x here, is equal to the sum of the 2 remote interior angles, which would be the 20-degree angle here and the 130-degree angle here. Now, remote interior angles are in reference to the exterior angle, which simply means that they're not adjacent to the exterior angle. Of course, this interior angle right down here that I called y just a little bit ago, that is adjacent to the angle marked x because they share this side between them of their angles. The remote angles are the ones that are not adjacent to it. But again, this angle theorem simply says that if I take the sum of those remote angles, so 20 degrees, plus 130 degrees, that is automatically equal to the measure of that other exterior angle. So, simply put, we need to add those two angles together, and 20 plus 130 in this case is 150 degrees, which means that the measure of angle x is 150 degrees. That's really all there is to it, which is kind of cool. So let's go ahead and briefly recap on the things that we covered in this video. First, we talked about interior angles of triangles and the angle sum property that says the three interior angles of a triangle always add up to 180 degrees. After that, we talked about the exterior angles of triangles and discovered what those look like, and also discovered that the three exterior angles always have a sum of 360 degrees. The final thing was the exterior angle theorem, which simply said that the exterior angle on a triangle is always going to be equivalent to the sum of the two interior remote angles, which you guys will be applying in just a little bit. Now, there are some other minor points that you guys will see in the actual lesson in our module, so make sure you are taking your time to go through it, as well as some really good practice problems for you to take your time working through before you guys get to your actual graded assignment. As always, good luck. Let me know if you have any questions, and I will see you guys in class soon.